This question is one that physicists love to give all the time. It says that two balls of the same size, but one weighs twice as much. So one's made out of wood, one's made out of lead, for instance. And we drop them from the top of a two-story building at the same instant. The time it takes for the balls to reach the ground is, and that gives us a bunch of choices. So we want to figure out essentially which one lands first, and do they take half as long? Is it the same time, or is it some other one but not necessarily half as long? Well, this condition is a two-story building. Say that my positive y direction is in the upward direction, and I'm going to release one ball. I'm going to just do this for one to begin with, and we're going to figure out how long does it take for the ball to hit the ground. Well, we know a few parts of this. We know that it starts from rest, so its initial velocity is 0. Its initial position is 2 stories. And we know that it's released near the Earth's surface, so our acceleration is equal to gravity. And I'm going to put that this is in the downward direction, just so I remember to do this correctly. So when I go through my problem, I know my final position as well. My final position is at the ground. When we're done, we're down, the ball's hitting the ground. So I look at the equations, and I find that the first of the two kinematics that we tend to learn, x equals x naught plus v naught t plus 1/2 a t squared, looks like a good one to use. And I remember that I have to be careful with my coordinate to make sure that I'm putting everything in the right way. So my final position is 0. My initial position is my 2 stories. My initial velocity is 0. I released it from rest. And my initial acceleration term, 1/2 negative g, g in my case is, g is equal to 9.8 meters per second squared. It's a magnitude, it's 9.8 meters per second squared. I've taken into account the minus sign because it's opposite of the direction that this coordinate is pointing. Gravity is pulling down, my acceleration is in the downward direction, so my gravity has to point in the negative direction as I drew my picture. Oh, and I got to put the t squared in there. So when I look at this, I get 2 stories minus this gravity term. This is going to be a pretty easy problem to solve. I can figure out the time for it. If I know what 2 stories is, I don't have that in SI units, but we could figure it out if we knew how tall a story was. The one thing that is interesting in this is absolutely no mass information came into play. Didn't happen. So it didn't matter which ball I was talking about. I did this for a general ball. If it would have mattered on it, we would have seen mass information. We would have seen something in kilograms show up, or something that had a unit of labeled m. But there is no m's and there's no mass units. So for these, in the absence of air resistance, they're going to feel the same, they're going to fall for the same amount of time. And this is Galileo's classic experiment off the Leaning Tower of Pisa. Drop 2 things, they hit at the same time. This doesn't seem like it should happen, but if you do this experiment, don't use things that are too influenced by air resistance. But if you take a bowling ball, and actually if you take a bowling ball and something even slightly smaller, like a golf ball, if you drop it where air resistance is not a huge issue, you will find that they do the same thing. They actually did this experiment on the moon, and they found that if you take a hammer and a feather, again, 2 completely different things, but no air up on the moon, and they hit at the same time. It's a really kind of a fascinating picture. I encourage you to go find a video of it if you haven't ever seen one.